Hi, my name is Salvador, and today I'm going to be doing my oral test. I'm going to be answering the question number 10. For this, I selected a partial fraction integral. We have 5x squared plus 3x minus 1 over 3 to the cube minus 2x squared plus x minus 2. This is a polynomial fraction, and to solve this integral, we need to do a method called partial fractions. We can substitute, we can't do by parts, we can use any method, but we can use the partial fractions method. The objective of this method is to simplify this bigger polynomial fraction into two or more fractions, which if we sum or add are going to give us this final or original polynomial fraction. First, we need to simplify the denominator into small binomials or small expressions. What I did here is to factorize by grouping, and I have two binomials. One is a quadratic binomial, and the other one is a linear binomial. And after that, we need to assume that we need to find a numerator for those expressions, those linear binomials. For the linear binomial, we need to find only one coefficient, which is going to be the numerator. We are going to call this number A. And for the quadratic binomial, we need to find two numbers because we have a quadratic binomial, so the numerator must be a linear binomial. So we need to find B and C, Bx plus C. After that, we can do a kind of equation because the original polynomial fraction is going to be equal to a over x minus 2 plus bx plus c over x squared plus 1. So what we can do is to the denominator of the left side, we can pass it multiplying by the right side of the equation. And if we can see from the first fraction, the x minus 2 or the denominator is going to be cancelled. The same happens for the second, but what it cancels out is the denominator, the different denominator that it has. So with that, we can do some algebra, which is multiplying the a for the binomial that is close to it, which is x squared plus 1, and the same happens for bx plus c. It will be multiplied by the other binomial. And if we do the algebra, we have the final sum of expressions, which is ax squared plus a plus bx squared minus 2bx plus cx minus 2c. What we need to do here is to make the grouping. The x squares with the x squares are going to be summed. The normal x, the linear x, are going to be summed, and the independent terms are going to be summed. What's the objective from doing this? If we can see in the equation, all the expressions from the x quadratic must be 5. The linear x must be 3, and the independent terms must be equal to minus 1. With that, we can do a system of equations. A plus b must be 5 because it's 5x squared. The c minus 2b must be equal to 3, and a minus 2c must be equal to 1. we need to do a 3 by 3 system of equations. And with that, we can use MATLAB, we can use Gauss-Jordan. But what I did was the algebraic process, which is only substituting the values. I make a substitution for A, which is 5 minus B, for C, that is 3 plus 2B, and with that, I only substitute those values in the third equation so that we can have a normal equation for finding B. The result for B was 0. For this result for A was 0. Was 5 for A because we substitute the value of B, which is 0. 5 minus 0 is 5. And for C, what I've got is 3. So we just need to substitute the values for A, B, C, and we have that our final and the fractions that we're going to integrate are 5 over x minus 2 plus 3 over x squared plus 1. We just need to do the integrals method. For the first one, we need to use the logarithm. The result is going to be 5 by logarithm, natural logarithm of the absolute value of x minus 2. And for the second one, the second fraction is going to give us 3 by the arctangent of x plus c, which these two ways of integrate are just formulas, just as simple. So the purpose of this method is to do the system of equations for finding the values of the numerators for our final fractions that we are going to integrate so that the integration part could be easy, as we can see. So that's all for my part. Thank you for watching.